Hello again, it's Cliff here from Down Under. There seems to be quite a bit of interest in ToolSetters, and so in this video I'm going to look more closely at these low-cost ToolSetters. This low-cost ETS, electronic toolsetter, and this low-cost mechanical toolsetter. Maybe we can call it an MTS. I'll have a close look at those and let you know my thoughts. So I bought this little electronic tool setter through AliExpress and received it a while ago, and planning to set it all up and see how it goes and possibly do a video of it. So it comes with a little compressed air nozzle for blowing chips off if you wanted to install that, and a plug on the end, and instructions, wiring diagram and so on. Looks like it's in Chinese only. So I thought I'd check it out first of all and just see the quality of construction and the quality of design. So let's do a couple of little checks of this ETS or electronic tool setter. Okay, it looks quite nicely made from the outside. It's got a real tungsten carbide ground top surface, so that's going to be very durable, and it is real tungsten carbide. Clean the bottom surface. Let's just see how level that ground surface is relative to the bottom. So let's see, we'll bring a dial test indicator into contact there with the top surface. I mean, it's important that this is level top to base, because when we are coming down with the tool or when we're sitting on the bottom of the spindle nose, it needs to be a level surface or it'll vary from one position to another. Just set this on 0. Well, that's not very level at all, is it? That's very poorly made. There we have an error between one side and the other. I'm just off 0 there, but about 50 microns. That's about 5/100ths of a millimeter. That's about 2 thou out, and it's out that way. And so it looks nice superficially, but we've got a big error there. That's not a good sign. And oh yeah, I can feel that whole vertical spindle slide is just flexible, so there's no stiffness or internal accuracy there. The design or the construction is internally very poor, and you could probably see the whole end rocking around. So there's probably a very small diameter vertical slide there. That's very poor. You're going to get a variation in positioning due to rocking of that vertical shaft slide, or whatever type of slide it is. So that is very poor quality. So anyway, that's a bit of an overview of a couple of issues I've immediately found. So I had a look online, looked at a few review videos of these cheap tool setters, and it seems they're a copy of a Metrol, a good quality Japanese tool setter, but they've sort of missed the boat in regards to quality. And I've seen some videos where they've been pulled apart, and they're really pretty poorly made with poor quality switches, very poor quality slides. They sort of look nice on the outside, but they're pretty rubbishy internally. And so I started to think, well, really, there's not much point in going to the trouble of wiring it all up and checking it out if I'm not going to be able to do accurate work with it or reliable work with it. Please note my criticism of this cheap ETS refers only to this particular manufacturer. You get what you pay for, I suppose. This was very cheap and it's very nasty, but it doesn't mean that all ETSs are cheap and nasty or will function poorly. For example, the Tormark ETS, I think it's over $1,000, and it's probably of very different design and construction and quality of manufacture. And there's probably other brands of ETS that are really well made. So I'm just referring to this particular one. I'm not sure of the name of it, but perhaps that will help you to identify it. Let's have a look. Here's this little cheap tool setter. It looks like it's refreshed at a different price again. US $39, shipping US 18. So I started thinking, well, perhaps there's a product here. Perhaps I could come up with a companion product to go with the Hallmark ITTP probe, which could be a superior design electronic tool setter. And I spent a few hours designing a better electronic tool setter and spoke to a few of my colleagues in the industry about tool setting and whether it would be a good product to develop. So I was looking at the R&D of a electronic tool setter, and you know, R&D, a big part of it is research and development, research, design and development. And the more I talked to people about it and did research, the more I realized that the application is much more limited for an electronic tool setter. Really, you're only setting the vertical Z position or the tool length into the tool table. Most users will only be using it for that, and it's a bit of overkill to have that system automated, especially when you consider that it's a highly risky product. I was thinking of developing one that was impact tolerant because you have problems if it comes down under an automatic probing routine and it doesn't switch off. And there's a whole lot of things that can go wrong. You know, your switching could be faulty, or you could have done something wrong and not had it connected up correctly. And so the tool's coming down under power, and that can do some real damage. It could damage your vertical ball screw and ball nut. It could damage your spindle bearings, could damage your tungsten carbide cutter. It could damage your electronic tool setter. And so that is a high-risk situation. So I started thinking, well, maybe an impact-tolerant tool setter would be a useful product. But it seems that there's quite a limited application. Only a few advanced users on these low-cost type CNC machines are going to be using an electronic tool setup to its full potential. Its full potential is when you've got an automatic tool changer and you've got different programs running, so that when your whole machine's running automatically and doing tool changes automatically, running all through the night, it can shift over automatically to this tool setter and check that the tool's not broken, check that it's worn, whether it's worn, and so on and so forth. And that's a really advanced use situation that probably won't be used very often in these low-cost CNC type environments. Maybe 1% of users would use it for that. The rest of the people are just going to use it for setting their tool length in the tool table. And really, for that application, something like a dial indicator type tool setter is almost as fast to use. So at the same time as ordering the electronic tool setter, I ordered this dial indicator type tool setter. I think it's called a zero setter, and it's just a dial indicator with a vertical plunger, and it has a very useful feature. Of course, where did I put my parallel? I've wandered off with it. I'll have to go and get that and carry on with this little story, but perhaps while I've got this in my hand I can show you a few of the features. So you've got a vertical plunger, a bit like a dial indicator, but a bigger diameter that suits the diameter of your cutter or drill or whatever, coming down on there, operating on the needle, and this is adjustable with a rotary dial on the front for adjusting your zero, and you can also adjust it with 3 little grub screws here to make a different adjustment, which is very useful. There's a grub screw in the back which goes into a keyway on the vertical slide to keep it in the correct rotary position. There's magnets underneath that allow you to stick it on the table. You could argue that's a bad thing if you're working with steel, but it's also a good thing in some applications. And then there's these 2 little buttons. Now I have to go away and find that parallel. Hold on a minute. Alright, I found it. So there's two little buttons here, either side. I think if you've seen my introduction video to ToolSetters, you'll see me using that. So that bridges the gap. That bridges those two buttons and pushes the plunger down to the same level height. And you can set the dial indicator here on 0, so that all three buttons, the central plunger and the two buttons, are producing a level surface, and the dial indicator needle is on 0. Now that's very useful because you can then set your probe onto one of these buttons, and the actual height of the whole body of the unit to the top of the button is a fixed height. I think it's made to exactly 50 millimeters in theory, but it doesn't really matter what that height is, but you can enter it into your software if you want to, whatever the height is, or it's just nice to have a fixed surface for setting your probe rather than trying to set the probe while that vertical plunger is on the 0 position. So that's quite a good little feature. So anyway, I got this at the same time through Alibaba as the automatic tool setter, the electronic tool setter, and the more I think about it, the more I think that this is probably a more practical solution for the average low-cost CNC user for setting the tool lengths, because you're only pushing one button and then you can load the length into your tool table. There's not a big saving in having your electronic tool setter for most users. So I've started thinking perhaps I'll put a hold on developing that impact tolerant electronic tool setter. You've got to do your market research, not just design something for the technical challenge. There's actually got to be a viable market for it. The little mechanical tool setter, US $28, shipping $13. Alright, well let's do some checks to that vertical plunger, because that's the vertical slide. You know, that's a ground diameter running up and down inside a bore with a dial indicator connected to it. So if that vertical plunger is loose, it's not going to be a very accurate vertical slide. I've just pulled it apart quickly and had a look at it internally, and it's quite well made. I haven't spent a lot of time studying it, so I'll pull it apart again and do some more tests, but I'll just put it back together for the introduction video, and it seems to work fairly well in practice. Let's just have a look. I'll put a dial indicator there on the diameter just to see what the clearance is between the plunger and the bore, the body. So let's have a look. Yeah, it's there. 2 micron dial indicator. So what are we getting? Yeah, it's about 2/100ths of a millimeter, just under a thou clearance on the diameter. That's not too bad. Well, you have a look at that. If I bias it right over one way and let it go, see how it's creeping back again? What's happening there is that the vertical plunger is moving like that. So it's sort of racking over in its clearance. It's gone back central. When I checked it before off camera, it went the whole other way. So anyway, it's a variable amount. But you know, there's only a thou or so clearance there. That's not too bad. And it seems to be stopping in the middle. So yeah, not too bad for the price anyway. So let's see how level it is on the top surface now. So if we just get this here. Now you could argue that you should be checking this when it's in its set position, in its 0 position, but we'll just quickly check it in its top position. Yeah, it's a little bit out. But that's this is a micron indicator, so we're only talking about 1/100th of a millimeter over that surface. Pretty good that way too. So the whole thing can float a little bit, so that if you are bringing a cutter down onto it, it will float by, you know, a hundredth of a millimeter within that clearance. So as long as you're central over that surface, it should be okay for sort of medium accuracy work. It's not too bad. It is a little bit out, but it's not too bad. I could dress the bottom of this whole body, put it on some carborundum wet and dry paper on a plate, and pressure down where it needs it to improve that. But because of the clearance in this vertical plunger, it's only has to be, it will never be a high precision setter, you know, but for the money, it's pretty good. Well, this little dial indicator style tool setter would seem to be quite a good option, so it's probably worth spending a bit of time looking at it closely. So let's just have a look at it. Perhaps I'll pull it apart now. So that's how you reset the dial, which is really convenient. There's also some screws on the side here, 3 little screws clamping onto the body of the dial indicator and holding it in place. So let's just undo those and pull the dial indicator right out. So I'll just hold the plunger in position and just pull the whole dial indicator out. So there you have a, where's that camera? There you have the basic dial indicator unit. So it's a rack and pinion style dial indicator. See it moving there. I'd say this is made by a dial indicator manufacturer specialist. Where's that camera? There you are. In China, who makes these by the thousand, and these are bought for a very low cost, you know, something ridiculous like $5 or something, and are installed into these units. Having trouble here seeing where the camera is. Installed into these units by the manufacturer of these, and the manufacturer of these tool setters just makes the block and the plunger with the magnets in the bottom of the block and so on. So this is just a spring-loaded plunger. Let's just pull it apart with a cap screw in the bottom, which acts as a stop to stop it from coming right out, and also a, where's my Allen key, a grub screw in the back operating in a slot. And if I take that grub screw out, or at least retract it a fair way, then we can pull the plunger right out, like so. And there's a spring in there. Oh, that operates the plunger. Okay, so obviously this plunger slides in there, and ideally that should be a very close fit. If it's too loose a fit, what would happen is that it would rack around inside that vertical bore, and it wouldn't be a very good bearing. Unfortunately, it's a little bit too loose of a fit. I did the measurements earlier. I think you saw that little clip. Funnily enough, it's quite tight to go in now, but once, it's probably because it's racked over, but once it's in, it's a reasonably loose fit. Now, I don't think that this is cylindrically ground or particularly accurate. I won't measure it on camera now, but it's not beautifully round, and the bore is not beautifully ground either. They're just sort of a bit rough and ready, but you know, what do you expect for the price? It looks like it's hardened steel, but it's not very hard, and I see that quite often with cheap copies. They make them look like they're hardened, but they may have only heated them up and quenched them in oil to make them look like they're hardened. I haven't hardness tested it, and it could be tough, but it's not glass hard. So that's disappointing. The vertical slide will rack around and rattle in there a little bit. And the next problem is that the dial indicator connects here. This little, trying to get this sort of so you can see it, this little peg that comes out the back of the dial indicator here, you can just see it there, is an extension of the dial indicator mechanism. That peg goes into there. Trying to get it silhouetted so that you can see it fairly clearly. And you see it there, there's a slot in the plunger that little peg, which is an extension from the dial indicator, goes into. Now we've got it. Now there's problems there because this whole plunger can rattle round, the peg enters in at a varying depth and a varying angle, and so that is not a good design. That is inevitably not going to be accurate because it's a loose fit on the slot, and that doesn't really matter because it's spring loaded, biased one way all the time, but the surface of the slot is varying in its angle due to the racking of the peg, and the keyway, which is on the other side here, is a fairly loose fit on the key so it can turn. So that little peg is free to move around in the slot on the surface that it contacts by angle and rotation. And that means it's going to settle into different positions. Well, it's at risk of settling into different positions at different times, and therefore affecting the actual needle position, because you can imagine that's critical to the needle position. And I've found that that's what happens in practice, that you can dial it all in and get it zeroing off nicely, and it will repeat 2 or 3 times, and then the next time you use it, it'll be a couple of hundredths of a millimeter out. Now those graduations, and this one anyway, are 2/100ths of a millimeter. You could probably buy imperial ones with thous, and it would fail to repeat from one time of use to another by about 2/100ths of a millimeter. So that's showing probably that little error in the connection between the dial indicator and the plunger. They are not connecting in a very well designed or constructed method, and I can't see an easy way to fix it. I mean, one of the problems was that the groove, the slot that's cut in there through there, I'm in a funny angle here, was roughly machined and all sort of ragged and horrible, you know, like one pass with a blunt cutter. And so I polished it with an oil stone. It did seem to be reasonably tough steel, so I've got the high spots out so that it's bearing a bit better, and I carefully cleaned the diameter and coated it with a nice slideway oil, put it all back together, and I was hoping that it would be better, and I've reduced its errors and reduced its problems with repeating down to a fairly small amount of about 2/100ths of a millimeter or a thou. But this is not a high precision, well-made device. I have to be upfront about that. I imagine that this is a copy of some other unit somebody else invented, maybe in America several years ago. It's been copied by a low-cost Chinese manufacturer, and they've sort of skimmed over some key points and made it down to a very low price. So you could buy one and fix it up and get it a bit better, as I have, but you'd be lucky to get it 100%. So that's a bit disappointing, considering that this is on the short list of a really practical machine tool setter. Another problem I had with it was that the dial indicator would stick, and I'd go around about 2 turns, and then it would catch, and then it would suddenly jump. And I pulled it apart in the end, and I finally figured out that the gears were possibly too close together, or there was a little bit of grit or dirt in there, and I didn't want to pull the whole dial indicator apart because it looks like it's not a doweled assembly, and so it would be very difficult to get all the gears set back again in place. So I used compressed air and fine instrument oil and just kept blowing on the gears and bearings, and it makes me cringe, but you know, it's a quick way to try and fix it. And I'd just about given up. And about the third attempt, the little bit of dirt must have been dislodged, and suddenly it went smooth and nice. So the dial indicator is quite well made, given the price it must have been manufactured for. It's just that at some point in its manufacture, or possibly in its assembly, when it was put into the body of the setter, some dirt had got in there, and I was able to get that out. So now it is operating smoothly, but I've still got that error with the plunger being a loose fit and the peg connection riding up on the little slot at different angles, causing a repeatability error of about a thou. So the dial indicator linkage pin bears in that slot against the bottom face. So I've been doing a little bit more lapping in the hope that a smoother surface will give me more repeatability. Probably won't make much difference, but you know, if you make a little change every time you pull something apart, it gets your hopes up, and hope's a great thing. So I've been lapping down in that face there with this very fine diamond lap. We'll just see whether that helps it. I might just luck on an angle change that happens to match the little pin better, or stop it from shuffling into a different position and gain a bit more repeatability. So putting it back together is fairly simple for the most part. I'm going to put that cap screw in there to act as a guide for the spring. We're going to drop the plunger in the right way round. I should really do it off camera and take a bit more time to get the surfaces cleaned and oiled. That's the grub screw in the back. Put this screw in here. So that limits the travel up there. So you tighten that up, it pulls the plunger down and limits the travel, just to stop it from falling out really. Then we put this dial indicator in and engage it with the slot. Now that's pretty difficult, because you really need to be about 3 millimeters tall to get in there, pull the little peg down and engage it, because once you put the dial indicator in, you've blocked your access, and so that had me stumped for a little while. So the trick to getting it together is to put a little bit of cotton around that peg, like a strong cotton, something quite small, or fine fishing line or something. Pull it down to about the right position so that you can then install it into the body, line it up with the slot in the plunger, and then once it's installed, pull the cotton out and it should stay in the slot, and then you can tighten up those 3 grub screws, that one and those two ones are at an angle, onto the body of the dial indicator. And that is useful because you can make a final rotary adjustment to get the actual face of the dial indicator in the right rotational position without and still leave this adjustment ring free, so that you can optimize the position of the needles and the horizontalness of the writing and so on. So that's nice to have that adjustment. So that's the way to get it back together again. I'll do it off camera so that I can clean it and put fresh oil on it, but that's the guts of it. So you can see that the design of this is that you've got a plunger operating separately from a dial indicator connected by that little peg, and that means that it must be very accurately made to work well. If you've got clearance in this plunger or poor workmanship in the connection between the dial indicator and the plunger, then you're never going to be able to attain accuracy. And so it's a sort of flawed design unless a bit of time and money is spent on making it right in the first place. In a way, a better design would be just to have a plain dial indicator, and then on the top of the dial indicator, where the little stylus tip is, fit a large flat plunger. Do I have anything within reach? You know, a large diameter button on the end. And that way everything is in line. You've got the slideway shaft slide of the dial indicator all in line. The whole thing has been designed as one unit. If you get a good quality one such as this Mitutoyo, it would be much more accurate, all things being equal, than this design with a dual mechanism. This is a single mechanism and in line. You probably need some sort of adjustment though, so that you could adjust it vertical, so that the little pad that the cutters come down on is not on an angle. It wants to be adjusted for sideways in front and back, so that it is perfectly level on the top surface in some way. It would be a nice feature to have, because I bet you if you made a little pad and screwed it on with a nice hardened and ground top surface, you put it all together and run a dial indicator on it, it'll probably be out in one direction. Something will be slightly out on that tiny little thread to the little pad, the little boss top surface. So I think it really needs to be adjustable. So I've been thinking about making something up, and I've ordered a small dial indicator, so I may make that up at some stage in the future. A dial indicator like this Mitutoyo would be really nice, but it's a little bit big, and you can see compared with this block, by the time I've got the pad on it and I've mounted it into a little mounting block, the whole unit is going to be about twice as tall as this unit. And that's not too much of a problem, but I thought I'd start with a smaller dial indicator as I could get anyway. I see that on the CNC Zone forum someone has already thought this through and made this exact instrument, which is a single dial indicator with a little pad on it in an aluminium or in a metal block. And that is a much simpler solution, and there's a lot less things to go wrong, much more likely to be accurate. So if you're thinking about a little workshop project, having a dial indicator upside down could be really the way to go. So this looks like a very similar idea. Edge Technology are producing something that looks like it's dial indicator based. That's quite intriguing. So the repeatability that matters with this is when you bridge across the three buttons, that surface is the same height from the work or the table of your machine. So obviously you've got to be careful that the parallel that's doing the bridging is clean and free from dirt. And if I just keep repeating, I don't know if it's much better. I'm getting 0, 0, 0. If I turn it, about 1/100th out. I'm sort of off to the side because of the camera, but yeah, you see if I twist the plunger by doing that, I can see the plunger twisting in its slop. I'm getting about a 1/100th error. That seems to be better than it was. I think I was getting 2/100th variation before. Now I'm getting about 1/100th. It's all lubed up, and I put some soft grease where the pin engages in the slot. It looks like it's about 1/100th now, but you know, it's one thing to get some results from a one test, but another thing to get the results from using it over several weeks. And it may or may not be an improvement. I was getting variations of about 2/100ths. It looks like it might be down to 1/100th. touch wood. Thanks for watching that rather long-winded videos, guys. Please let me know your thoughts. Thanks.